Static resources are one of the most consistently misused features in Salesforce development. Developers either ignore them entirely and reach for content version when they should not, or they reference them the wrong way, pasting a URL that Salesforce will silently invalidate on the next deployment. This tutorial covers the full picture: what static resources are, how to upload them correctly, how to reference them in Apex and LWC, and the specific mistakes that will cost you a production incident if you have not encountered them before. Before writing any code, you need to understand what static resources are actually for. Every Salesforce org ships with 250 megabytes of storage specifically for application assets, JavaScript libraries, CSS files, images, fonts, and configuration JSON. The critical word is application. These are files that are part of your code, not files that users upload or share at runtime. That distinction matters because choosing the wrong storage type gives you the wrong access pattern, the wrong version control story, and confusion in the org down the line. The most common mistake happens before anyone writes a single line of code. A developer uploads a resource through setup, sees the file in the list, and copies the URL from the browser, something like /resource/1712345678000/myLibrary. They paste it into their LWC or Apex class. It works in the sandbox. They push the code. Then a deployment happens in production. The timestamp changes, and the reference is dead. There is no error thrown in most cases. The library stops loading, and the component silently breaks. A static resource is a file or a zip archive containing multiple files stored inside your Salesforce org and delivered from Salesforce's content delivery infrastructure. The types that belong here: JavaScript libraries like chart.js or jQuery, CSS style sheets, image bundles, font files, and JSON configuration files such as feature flags or lookup tables. The maximum size per individual resource is 5 megabytes. The API name you assign is how every reference is made in LWC, Apex, and Visualforce. Choose a name that is stable and namespaced if you are shipping inside a managed package, because references break if the name changes after deployment. You can upload either a single file or a zip archive. Single files are straightforward: one JavaScript library, one image, one style sheet. Zip archives are for situations where a library ships with subdirectories, or where you want to bundle related assets under one resource name. When you upload a zip, Salesforce stores the whole archive. You then reference individual files inside it by appending the internal path to the base resource URL. Think of the zip as a folder and the appended path as the file location inside that folder. The path must exactly match the structure inside the archive. Cache control has two settings: public and private. Public means Salesforce serves the file through its CDN. Edge nodes cache it, so the file loads faster for every user on every subsequent request. Private means the file bypasses CDN caching and is fetched fresh for each session. The rule is simple: library files and style sheets should almost always be public. Only use private for assets containing org-specific or user-specific information that should not be shared across sessions, which is rare for the types of files that belong in static resources. Setting a public library to private slows every user down with no security benefit. Uploading through setup is the manual path. Navigate to setup, then custom code, then static resources, then new. The name field becomes the API name. Alphanumeric characters and underscores only, no spaces or special characters. Choose your file, or a zip if you are bundling multiple assets. Set cache control. Save. The MON type is inferred from the file extension automatically. For zip archives, Salesforce stores the whole package and lets you reach files inside it by path. This method is fine for one-off uploads. For anything version controlled, use the CLI approach instead so the file travels with your code. For projects under source control, which should be every serious org, the correct upload method is the metadata API or Salesforce CLI. Your static resource lives in the source directory as two files: the actual resource file with a .resource extension and a companion metadata descriptor with a .resource-meta.xml extension. The descriptor declares the content type, the cache control setting, and an optional description. Deploy with the SF project deploy start command. This means your library files travel with your code through version control, pull requests, and CI pipelines, the same lifecycle as any other source artifact in the project. In Apex, there are two things you might want to do with a static resource: get its URL so you can pass it somewhere, or read its content if it is a text file like JSON. Forgetting the URL, use page reference for resource. Pass the resource name as a string and call getURL on the result. The URL returned includes the current version timestamp that Salesforce manages. You never need to know what that timestamp is, and you should never attempt to construct it manually. For a file inside a zip archive, use the two-argument version of forResource, passing the resource name first and the internal file path second. Reading static resource content in Apex is the right approach when you have a JSON configuration file or XML template that your logic needs at runtime. Query the static resource object directly. It has a body field that returns the file content as a blob. Call toString on the blob to get a plain string. Then use JSON.deserializeUntype to parse it into a map if the content is JSON. One critical performance point. Cache the result in a static variable inside your class, so the SOQL fires only once per transaction, no matter how many times the method is called. This is an important governor limit consideration. In Lightning Web Components, importing a static resource is a single declaration at the top of your JavaScript file. You write, import my logo from its Salesforce/resource URL/your resource API name. The platform resolves the current version URL at component load time and gives you a string you can bind directly in your template. For a single file resource, an image, a standalone script, that string is the complete URL. Assign it to a property and reference it in your HTML using standard curly brace property binding. No Apex call, no manual URL construction, no hard-coded paths anywhere in the component. When your resource is a zip archive, the import gives you the base URL of the archive, not a direct file URL. To reach a specific file inside the zip, concatenate the base URL with the internal path using a /chargesbase+/chart.umd.min.js. Do not add a leading slash to the path portion. That creates a double slash and produces a 404. Think of the base URL as the address of the folder and the path after the slash as the file name inside that folder. The path must exactly match the file structure inside the zip, including any subdirectory names. The Lightning/Platform Resource Loader module gives you two functions, loadScript and loadStyle. LoadScript takes the component instance, always the this keyword, and a URL string, injects a script tag into the DOM, and returns a promise that resolves when the script has finished executing. LoadStyle does the same for CSS, injecting a link tag. Both functions are idempotent within a page. If multiple component instances on the same page request the same URL, the platform only injects it once. Always call these inside connected callback, not rendered callback, unless you have a specific rendering dependency that requires otherwise. Some libraries depend on each other and must load in a specific order. If you load selectIze before jQuery is available, selectIze will throw an error because jQuery is not yet defined in the global scope. You handle this with promise chaining. Call loadScript for the first library, then in the dot, then callback call loadScript for the second, and so on. Each step waits for the previous one to resolve before beginning. A single dot catch at the end handles any failure in the chain. This pattern is the correct way to express ordered dependency loading in LWC. No timeouts, no polling. The most common mistake with static resources is hard-coding the version URL path. When you navigate to a resource and setup and copy the URL, something like /resource/171234567 you are copying a path that contains a timestamp Salesforce generates and controls. That timestamp changes every time the resource is redeployed. The moment someone runs a deployment, every hard-coded path breaks silently. In most cases, there is no visible error. The library stops loading, and the component fails without any indication in the console. The fix is always at Salesforce/resource URL in LWC and page reference for resource in Apex. Never copy the URL from setup. The second common mistake, calling loadScript inside rendered callback without a guard flag. Rendered callback fires every time the component re-renders, which can happen many times during a component's lifecycle, triggered by property changes, parent re-renders, or reactive data updates. If you call loadScript without checking whether the scripts have already loaded, you inject the same script tag into the DOM repeatedly. This wastes resources and can cause libraries that initialize themselves on injection to run their setup code multiple times, producing unexpected behavior. The fix is a simple Boolean property called scriptsLoaded. Check it before calling loadScript and set it to true after. The audit for action step 1 is a simple search. Open each LWC JavaScript file and search for the string resource followed by a number. If you find it, you have a hard-coded version path. Add an import declaration at the top of the file. Import resource name from its Salesforce /resource URL /your resource API name, and replace the hard-coded string with the imported variable. This is a direct one-for-one swap that does not change how the component behaves when it loads. But it guarantees the reference will survive every future deployment without breaking, because the platform resolves the version at load time rather than at code write time. For action step 2, navigate to Setup, Custom Code, Static Resources, and review the cache control column for every resource in your org. Any JavaScript library, CSS style sheet, image file, or font file should show public. If you see private on one of these, edit the resource and change it. Setting private on a library like chart.js means every request bypasses the CDN and goes back to Salesforce's origin servers. Measurably slower page loads for every user who hits a component using that resource. There is no security benefit from caching a standard public library privately. It is a performance cost with no upside. For action step 3, examine your Apex classes that read static resource content by querying the static resource subject. If those classes issue the SOQL directly without any abstraction, they are integration tests in disguise. The static resource SOQL only works in test context if the resource physically exists in the org, which means a test that queries it directly cannot run in a fresh scratch org without org state setup. Add a virtual method or a selector interface that can be overridden in test context, injecting a mock blob directly. Your unit tests then run without org dependency and execute reliably in any environment, including CI pipelines. The full article covers everything in this tutorial with complete, working code examples. The Apex helper class for URL generation, the static resource reader with lazy loaded caching for JSON configuration files, a working chart.js integration in LWC with sequential dependency loading, and the full image gallery component using a zip resource. It also covers namespaced static resources in managed packages, the Visualforce URL for equivalent, when to reach for custom metadata types instead, and the content version comparison. Read it at realsyllabus.com. If this tutorial was useful, the newsletter delivers one concept like this every week.